Imagine taking something completely ordinary and transforming it into something truly extraordinary, like turning a pair of old socks into a brand new video game console. It sounds impossible, right? But throughout history, people have always dreamed of making the impossible possible. For centuries, alchemists were obsessed with the idea of turning mercury, a common silvery liquid metal, into pure, gleaming gold. Gold was the symbol of wealth and power, and the idea of creating it from something cheap fascinated them. These early scientists tried every trick in the book, mixing mysterious potions, chanting spells, and experimenting with all sorts of strange flasks and bubbling concoctions. But no matter what they did, their efforts always fell short. To most people, alchemy was nothing more than magic, a fantasy world of dreams and illusions. But what if I told you that thanks to modern science, we can now do what those ancient alchemists only imagined? Today we can actually turn mercury into gold. Not with magic or trickery, but with the power of nuclear science and technology. By unlocking the secrets of atoms, scientists have discovered a process that feels almost like wizardry: nuclear transmutation. This is real science, not a sleight of hand. We now have the ability to literally change one element into another by rearranging the fundamental building blocks of matter itself. Think of it like baking a cake. If you swap out just one key ingredient, you end up with something completely different. The same principle applies to atoms. In the world of atoms, that crucial ingredient is the proton. Change the number of protons and you change the element. Add or remove a proton, and suddenly, mercury is transformed into gold. It's that simple, and that mind-blowing. We'll take you on a journey from the dusty, candle-lit workshops of ancient alchemists to the cutting-edge, high-tech laboratories of today, where scientists use advanced tools to reveal how a tiny difference in atoms separates mercury from gold. Together, we'll uncover the hidden secrets of the atom and see how scientists use massive machines, like particle accelerators, to perform what can only be described as modern-day alchemy. This is the incredible story of how science has made the impossible possible, turning ancient dreams into reality. Get ready to explore one of the most fantastic and awe-inspiring feats in the history of science. Because when it comes to transforming the world, science is the real magic. Before scientists, there were alchemists, part philosopher, part chemist, part mystic. Across Egypt, China, Greece, and medieval Europe, they chased one dream: making gold. Gold wasn't just wealth, it symbolized perfection and immortality. Alchemists believed all metals were on a journey to become gold, and the philosopher's stone was the key. They thought the right recipe could transform sick metals like lead or mercury into gold. This obsession made sense. Gold meant power, security, and a better life. The promise of unlimited wealth drove their experiments. While they never made gold, their work wasn't a failure. Alchemists invented techniques like distillation and fermentation, and discovered new elements. Their magical quest laid the groundwork for real science chemistry. They asked the right questions, even if they lacked the tools for answers. Their dream set the stage for future discoveries. The pursuit of gold led to a treasure trove of scientific progress. Sometimes chasing the impossible leads to the most valuable breakthroughs. The alchemist's legacy is the birth of modern science. To even imagine turning mercury into gold, we have to zoom in, way in, down to the tiniest scale imaginable, the atomic level, where the very fabric of matter is woven together. Atoms are the universe's building blocks, like tiny Lego bricks snapping together to create everything we see, touch, and experience in the world around us. Each atom has a dense nucleus at its center, made of protons and neutrons, surrounded by a cloud of electrons whizzing around. The number of protons in the nucleus is what defines an element, like an atomic ID card that tells you exactly what kind of atom you're looking at. For example, hydrogen has just one proton, while carbon, the basis of life, has 6 protons in its nucleus. Mercury and gold, two fascinating metals, sit side by side on the periodic table, almost like neighbors in the same atomic neighborhood. Mercury's nucleus contains 80 protons, while gold's nucleus has 79 protons, just one less. That's it. The only difference between these two elements is a single proton, a tiny change with huge consequences. The alchemists of old failed in their quest because they tried to change metals using chemistry. But the real transformation happens much deeper, inside the nucleus itself. To truly turn mercury into gold, you need a nuclear reaction, not just a chemical one, something far more powerful and complex. It's like changing the blueprint of a house, not just repainting the walls. The structure itself must be altered at its core. The true identity of an element is locked deep inside the atom, hidden within the nucleus where protons and neutrons reside. To make gold from Mercury, you have to remove one proton from Mercury's nucleus, a process called nuclear transmutation. This is the heart of nuclear transmutation, where the very nature of matter is changed at the most fundamental level. The tiniest change, a single proton, can make all the difference, transforming one element into another. Welcome to the world of atomic alchemy, where science meets the dreams of the ancients and the impossible becomes possible. The secret's out. Mercury and gold differ by just one proton. But removing a proton isn't easy. The nucleus is held together by the strongest force in the universe. You can't just pluck a proton out, it's locked in tight. Chemical reactions only affect electrons, not the nucleus. To change an element, you need to overcome the strong nuclear force with immense energy. The trick is to make the Mercury nucleus unstable so it wants to change. If you add the right energy or particle, the nucleus can become unstable and decay. During radioactive decay, the atom can lose a proton. If Mercury loses a proton, it becomes gold. This is nuclear transmutation, modern alchemy at work. The alchemists had the right dream, but the wrong tools. Today we target the nucleus, not the surface. Science gave us the power to rewrite the atom's blueprint. It's not magic, it's physics, and it changes everything. So, how do we actually turn Mercury into gold? Enter the nuclear reactor, a machine that unleashes a storm of neutrons. First, you need a rare isotope, Mercury-196. Separating it from regular mercury is expensive and tricky. Place your purified Mercury-196 inside the reactor's core, where uranium atoms split and release neutrons. When a Mercury-196 atom absorbs a neutron, it becomes Mercury-197, an unstable isotope. This unstable atom undergoes electron capture. It grabs one of its own electrons, turning a proton into a neutron. Now the atom has 79 protons, making it gold. Specifically, it becomes gold-197, the only stable, naturally occurring gold isotope. This process is nuclear transmutation in action. It's not about potions or spells, but precise nuclear physics. The recipe is real, but it's far from practical. Still, it proves that science can do what alchemists only imagined. Modern alchemy is a triumph of technology and understanding. This isn't just theory, scientists have actually made gold from other elements. What once seemed like pure fantasy, a legend from the days of ancient alchemy, has become a reality in the modern laboratory. In 1941, researchers at Harvard and Berkeley used a particle accelerator to bombard Mercury with fast neutrons, pushing the boundaries of what was thought possible at the time. The collisions knocked protons out of Mercury nuclei, transforming them into gold atoms, an incredible feat of nuclear alchemy. It was the first time humans achieved the alchemist's dream, turning one element into another through sheer scientific ingenuity. In 1980, Nobel laureate Glenn Seaborg's team used a powerful accelerator to smash bismuth atoms, knocking out 4 protons to make gold, further proving that transmutation was possible. These experiments weren't about getting rich or making jewelry, they were about pushing the frontiers of human knowledge and discovery. The gold produced was microscopic, detectable only by its radioactive signature, invisible to the naked eye, but unmistakable to sensitive instruments. The real value was in the knowledge gained about atomic structure and nuclear forces, insights that would shape the future of science. Each successful transmutation revealed more about the universe's building blocks, unlocking secrets hidden deep within the atom. The gold was too little to see, but the scientific breakthrough was enormous, opening doors to new possibilities in physics and chemistry. These experiments proved we could rearrange matter at the most fundamental level, changing our relationship with the elements themselves. The dream of alchemy became a reality, thanks to science, determination, and the relentless curiosity of researchers. The journey from myth to experiment changed our understanding of the universe, bridging the gap between imagination and reality. Making gold was just the beginning, a symbol of what humanity can achieve when we dare to explore the unknown. The true treasure was discovery itself, a reward far greater than gold. If we know how to make gold, why aren't we all rich? The answer: cost, efficiency, and safety. Building and running a nuclear reactor or particle accelerator costs billions. Separating the right mercury isotope is outrageously expensive. Even after all that, you get only a few billionths of a gram of gold, worth pennies. The electricity alone costs thousands of times more than the gold produced. Plus, the process creates dangerous radioactive byproducts. Extracting the tiny bit of gold from this radioactive mess is risky and costly. The gold itself may even be slightly radioactive, and if we could make gold cheaply, its value would crash. The rarity of gold is what makes it precious, so mining gold from the earth remains the only practical option. Was all this research a waste? Not at all. The real treasure is the science we discovered. Nuclear transmutation has revolutionized medicine. Particle accelerators create custom radioactive isotopes for life-saving scans and cancer treatments. Isotopes like technetium-99m, made in reactors, are used in millions of medical procedures every year. This technology is a direct descendant of early gold-making experiments. Transmutation also helps us understand the universe. Elements like gold are forged in the hearts of stars and supernovas. Every atom of gold on Earth was created in a cosmic explosion. Studying transmutation in labs helps us answer big questions about the cosmos. The knowledge gained is far more valuable than gold itself. Science turns stardust into understanding. The journey from alchemy to nuclear physics shows what science is all about: curiosity, big questions, and real answers. Alchemists dreamed of gold, but lacked the rulebook. Modern science revealed the atom's secrets and made the impossible possible. We can turn mercury into gold, but wisdom tells us not to. The real value is in the knowledge, life-saving medicine, cosmic understanding, and technological breakthroughs. This story inspires us to keep asking, what's impossible today? Curing all diseases, traveling to the stars, understanding consciousness. Like the alchemist's dream, these challenges push us to explore and discover. The journey of discovery is its own reward. Next time you see gold, remember its cosmic story and the humans who dreamed of making it. Science lets us unlock the universe's deepest secrets. The world is full of wonders waiting to be explored. Stay curious, science rules.